Okay. I'm going to try to get in the first part of this really quickly and go over what we've got. So the very first thing is on your phase diagram worksheet. This is the tutorial at the top. Okay, and this tells you what the different things are, and so it says a phase diagram is a graphical way to depict or to look at the effects of pressure and temperature on the phase of a substance. So the curves indicate the temperature and pressure under which equilibrium, okay, that's the equal between different phases of substance can exist. So both phases exist on the line. So these lines that I traced in red, those are those curves that they're talking about, okay? And so both phases, so you can see here, this line would show your melting freezing points. So if something lands on that line, here, vaporization, condensation, and sublimation, deposition. And you will always have solid, liquid, and gas. And again, we are looking at on our y-axis the pressure and on our x-axis the temperature. So if you increase the pressure going this way and you increase the temperature going this way, then you can see at different things that you're going to have. And you're going to treat your pressure and your temperature just like an x and y coordinate. And then you're going to follow it up to see where that point actually lands. So over here, melting and freezing, sublimation, deposition, vaporization, condensation, just basic definitions. And down here it talks about the critical point. We're going to leave the critical point. What it says is a temperature above which gas cannot be liquefied no matter how much pressure is applied. Kinetic energy is far too great for the attractive forces to overcome, and any substance beyond the critical point is known as a supercritical fluid. It's indistinguishable. Indistinguishable. You cannot tell between the gas or the liquid. It's neither one. So we're going to leave this part up here for your upper level physics and chemistry classes. We're not going to really even deal with that. We're just learning how to read the graph. The triple point, it says the triple point is here. The triple point is the condition of temperature and pressure where all three phases exist in equilibrium. So at this point, with this temperature at this pressure, whatever this is, wherever those two things line up, at that point it can be a solid, liquid, and or gas. You should have all three states of matter present. So remember that pressure can be expressed in three ways. We're just going to look at pressure as 1 atmosphere. We're not worried about that other stuff. Again, I'm going to leave your kilopascals and your millimeters mercury to your upper level teachers. So what we're going to do today is we're going to learn how to read this graph. So what I did is I took the graph that you have and I marked it into 3 quadrants, or not really can't be 3 quadrants, that doesn't make any sense, but I marked it into 3 sections. All right, so this had your y, I call it a y, but your curves, right? And then you had your triple point, and then this line here was part of it, so that's your melting freezing line. And this here, this line is going to be your sublimation, your vaporization condensation line. This line from this point underneath is going to be your sublimation deposition line. So everything underneath this line
detention will be held in the gym. After school detention will be held in the gym.
Anything that falls here is a liquid, and anything falls in here is a solid. So, just like being here. All right. So the normal temperatures and the normal what you call STP is standard temperature and pressure. So our standard temperature and pressure is 0 degrees Celsius and 1 atmospheric unit. So if I'm looking for, like in this case, the normal freezing point is 100, because the freezing point normal is at 1 atmospheric pressure. So when I go over 1 atmospheric pressure, the freezing point is going to have to land on that line. And if I go down, I find out that that's 100 degrees Celsius. Then the normal boiling point, again, 1 atmospheric pressure is normal, okay? So I'm going to follow this over into where these two things meet. So I put down that that's about 330 degrees because it's not quite 350 where those kind of line up, okay? If I look right there, okay? On the back side, you have, it says, what is the normal melting point? So the melting point, remember, is going to be the same as your freezing point, because this is freezing and melting, right? So this is your freezing and melting line. So it should be 100 degrees Celsius, right? 100 degrees Celsius. is the normal. Then what you're going to do for these is you're going to look at these almost like ordered pairs. So I'm going to go to my graph and I'm going to look at, it says what is the phase, solid, liquid, or gas, of a substance that's 2 atmospheric pressures and 100 degrees Celsius. So we're going to look at that really quickly. So it's 2 atmospheres and 100 degrees Celsius. So I'm going to go to 100 degrees Celsius, 2 atmospheres. I'm going to follow those up. And that point would land right here. Well, that's the solid range. So that's going to be a solid.
Pardon the interruption, high school teachers, just a reminder that we will have...
Over here, we have number 6 says, what is the phase, solid, liquid, gas of a substance?
Also,
at
we have snacks and
0.75
drinks for you
ATMs
in the high school
and
conference room.
100 degrees
Open house.
Celsius.
Students reminded that we
So
have open house
if I
tonight,
look at
4 to 6.
0.75 at 100 degrees Celsius, I'm going to fall right in here inside this Y. I'm technically just over it, but that doesn't matter. I'm not on the line. So this is going to be a liquid. Okay? So what I am is I'm looking at these things as almost like ordered pairs. So if you want to look at those things in ordered pairs, and you should get, let's look at these answers here. Okay. So we're at number 7. Number 7 should be a gas. Number 8, solid. Number 9, liquid. Number 10, gas. Okay, so that's the way it should be. Then it says what condition is the triple point of the substance. So it wants the temperature and the pressure. If you look back at your graph, this triple point is right here. Okay, and so we want the temperature and the pressure. So when I follow this down, it's not quite 100. And then when I follow this over, it's not quite 0.75. So we got to use some estimation skills. I said 75 degrees Celsius and 0.7 atmospheres. Anywhere around 75, 80 degrees Celsius or 0.6, 0.7 atmospheres would be appropriate to answer that question. Be in the range. All right, so I'm going to pause the video there, and then we will go over the next part in the next video. So when you finish this video, switch to the next one to see the rest of the answers.